Today's lesson is going to be on real numbers in the number system. So you will get out your notes from today, or your notes that I gave you to take home today, and you can copy them on here. So the real numbers, all of our real numbers, any number that we can think about is a real number. And we use, the pen tool, obviously. But we use this capital R for real numbers. What are some examples of real numbers? 2, -2, pi, 5 halves, 2.6. These are all examples of real numbers. Our real numbers are divided into two sets, irrational numbers and rational numbers. I'll talk about irrational numbers first. Our rational numbers are designated with the capital letter I, and these are decimals that have no ending or have no pattern. So what does that mean? A decimal that doesn't end might be 5.26719.8 ... going on, and there's no real pattern to it. And it never ends either. Another one would be pi, which is 3.1415, on and on, and not forever, but there's no pattern. So what are our rational numbers? Rational numbers are fractions and decimals that have a pattern and that have an end. And since our R is used to denote real numbers, we use a Z, capital Z, for rational numbers. And these are fractions, 5 halves, 2.5, -3, because remember a whole number is just a fraction over 1, 0, 2.76, 3.9 repeating. Those are all rational numbers. Our set of integers, also an I, these are our positive and negative whole numbers. So think -3, -2, -1, 0, 1, 2, on and on. Our whole numbers include 0, so 0, 1, 2, 3, 4, on and on. What's the difference between integers and whole numbers? Integers have your negative numbers in with them. Whole numbers do not. And then you have your natural numbers. So these are your counting numbers. 1, 2, 3, 4, on and on forever. The difference between natural numbers and whole numbers, what is it? If you said that whole numbers include 0, you were right. Natural numbers do not include 0. So we're just going to denote which ones these all belong. 30 is real. It's rational. Is it an integer? It is. It's whole. And it's natural. So all of these numbers here are numbers that we have heard of before, so we can already say that these are real numbers. For the purpose of this course, we will not be talking about non-real numbers. So what numbers are irrational? Your square roots that are not perfect square roots are irrational. Because if you take the square root of 21 and your calculator, you get a number that is a decimal but doesn't have a pattern to it or is repeating in that form. What about negative square root of 9? This is -3. Is -3 irrational? No, it's not. Number 7, I'm going down instead of across. Real, it's rational. keyword there is ratio, so it can be written as a ratio. 6 to 3 is a ratio. Is it an integer? Well, 6/3 is 2, so that's an integer. It is whole and natural. What about 0? Oh, no, I'm sorry, -11. -11 is real, that's rational. It's an integer. Is it a whole or natural number? It's negative, so it's not. 0 is a real, rational, and it is whole, but not a natural number. Pi. We talked about pi already. Pi is irrational. -3 is real, rational, and integer. What about 5.3 repeating? Does this repeat in a certain fashion with a pattern? It does. So this is real and rational. But is this a whole number or an integer? No, it is not. I think I forgot on number 6 that, oh, it is an integer. So what I would like you to do, you have something, you have this on your worksheet. I want you to put the letter of each value in the correct location. So for instance, 7. Number 7 is not irrational, but it's rational. 7 is an integer, 7 is whole, and 7 is natural. So I want you to put A in the natural circle for 7. I want you to do this on your own, and there will be some submission for you coming up. You can pause here while you complete this, and then move on. This practice, which expression does not name an integer, which expression represents an irrational number, and which number is not a whole number. These 3 questions are going to be on your Canvas homework assignment, so make sure you look to this at the end of the video. Also, these will. All right, estimating square roots. Your steps for estimating square roots. Think about the square roots. What are the perfect squares that we have? What is a perfect square? Remember, to square something means to multiply it by itself. So, for example, 1 times 1 is 1. 2 times 2 is 2. I'm sorry, it's too early in the year. 4. 3 times 3 is 9. 4 times 4 is 16. These numbers, 1, 4, 9, 16, are all called perfect squares. Okay? So to estimate square roots, because they're not all perfect, you need to first identify the 2 perfect squares. The radicand, that's the number underneath the square root symbol, is between. So, for example, the square root of 15. 15 is between 16. 16 is a perfect square, and it's between 9. So 9 and 16 is between those 2 perfect squares. That's step 1. Then you find the square roots of the perfect squares. So what's the square root of 3? I'm sorry, square root of 9. It's 3, I gave you the answer. And what's the square root of 16? It's 4. And then write your estimate. So we know that this square root is between 3 and 4. Is the square root of 15 closer to 16, or is it closer to 9? Right, 15 is closer to 16, so your answer is going to be closer to 4. You're not going to estimate by saying 3.8 or 3 point anything. You're just going to say it's between 3 and 4, and then if you draw it on a number line, you would draw that number closer to 4. So how about the square root of 60? Let's see. My 60, we have 60, 61, 62, 63, 64 is a perfect square. That's 8 times 8. And then all the way, let's see, so if 8 is our larger one, that means our 7 is our smaller one, which is 49. So 49 is our perfect square. So square root of 60 is between the square root of 49 and the square root of 64. So it's between 7 and 8. And is 60 closer to 64 or is it closer to 49? It's closer to 8. So this is somewhere between 7 and 8. The square root of 5. Oh, I know that the square root of 4 is really close there. That's 2. And then 2, the next number is 3. So that's going to be the square root of 9. Is the square root of 5 closer to the square root of 4 or the square root of 9? And the answer is it's closer to the square root of 4. So that's closer to 2 rather than 3. Then we have the square root of 23. The square root of 25 is our high one, and the square root of 16 is our low one, which is going to be 4 and 5. Which one is it closer to? Closer to 5. Comparing real numbers. When we compare real numbers, we use these symbols. Less than or equal to, greater than or equal to. So if I look at these, how does negative 3.1 compare to negative 16 over 5? Well, we need to know what 16 over 5 is, first of all. I know that 5 goes into 16 how many times? 3. So it's negative 3, but do we know what it is? You won't hear me say to use a calculator very often, but if you use 16 over 5, you see that? You'll see that it's negative 3.2. So which one is larger? Which one is smaller? Remember, these are negative numbers, so the bigger your number looks, the smaller it is. So this negative 3.2 is our smaller number, and negative 3.1 is our bigger number. To put this in our elementary way, the alligator eats the bigger number. So negative 3.1 is greater than negative 3.2. All right, so what about number 2? How does 4/3, which that is about 1.333, compare to the square root of 2, which is 1.41? The bigger number is 1.41, so that is 4/3 is less than 1.41. And how does 9.6 compare to the square root of 96, which is 9.79? 9.79 is greater than 9.6. 9.6 is less than 9.79. Why did I do that? It's because we need to know how to order these numbers. On a number line, we need to be able to put them in their place. So 0.5 is relatively easy. 0.5 goes somewhere between 0 and 1. So 0.5. Negative 2, obviously, is at negative 2. What about the square root of 5? Well, we said earlier that the square root of 5 is between the square root of 4 and the square root of 9. So that's between 2 and 3. And it's closer to 2. So we're going to put the square root of 5 about right there. What about negative 7 over 4? That is negative 1.75. All's there. And then 2.4. Ooh, that's almost 2.5, so that's going to come here. When I put this in order, negative 2, negative 7/4, 0.5, square root of 5, and 2.4. Yes, this will be represented on your test that's coming up next Friday, so you need to be prepared for this. What I want you to do is have this you try. I want you to bring this you try in for homework, and I want to see who all is listening. If you bring this in on a small piece of paper in the correct order, or if you bring it in on an index card and show it to me, I will give you some extra credit, just because I want to see who's actually listening to the video or watching it all the way through. Nope. Go forward, not backward. And that is the end of today's assignment or today's video. I need you to go on Canvas now and take your homework quiz. It shouldn't be too long, and remember, as with the last video, you can absolutely retake it because I want you to get a 100. So if you don't do well the first time, go and retake it for another grade. Have a good night.